on what is translation. Translation is a transformation in which a figure slides along a straight line and changes its position without turning. This is a congruency transformation in which the object and the image are the same size. Importance of translation in nature and in the real world is if you push a heavy box across a room, the box is translated. When a fireman slides down the pole at the fire station to respond to an emergency, the fireman is translated. When a person is doing an MRI on his head, he is translated in and out of the MRI machine. Properties of translation. Translation preserves the distance between points, hence preserving length. Translations preserve angle. The corresponding angles are the same after the translation, and translations preserve parallelism. So parallel sides remain parallel after translation of an object. Translation preserves area. Area of the figure remains the same after translation. And translation also preserves the order of our problem, in which it says the vertices of a triangle ABC are -3, 2, -6, 4, and -7, 2, respectively. Plot the points on a sheet of graph paper and join them. Determine the vertices of a triangle A inverse, B inverse, C inverse. Under the translation 7, -3. Now let's try to use a graph paper. Alright, so we have a graph paper here, and we are going to try to plot our point. Transformation matrix T plus the matrix is equal to P inverse. Try to plot our points. Point A is equal to a -3, 2. B now is a -6, 4. And our C point is a -7, 2. Try to join these points. Okay, that is our object with the coordinate. Alright, so remember, we were given our transformation matrix T equal to 7 minus 3. The transformation matrix plus our image matrix. Alright, so our coordinates for A would be a -3 and 2. Coordinates for B would be a -6 and 4. Coordinates for C would be a -7 and 2. Alright, we still know that to add matrix, we're using row by column. In following the row time column procedure, in which going across 7 and the -3, we say 7 minus 3, right? Row times column, right? Then we should say 7 minus 6 in row 1, and then we say 7 minus 7. We're going down now. We have a -3 plus 2. Then we have a minus 3 plus 4. We have a minus 3 plus 2. Okay, we're going to simplify that and tidy it up to get our A inverse, our B inverse, our C inverse. Okay, alright, so we have 7 minus 3. We have a 4, a minus 3 plus 2. We have a minus 1. Then we have a 7 minus 6. We have a 1. And we have minus 3 plus 4. We have a 1. Then we have a 7 minus 7 give us a 0. And minus 3 minus 2 we have a minus 1. Okay. Actually, now we are ready now to plot our image matrix. All right. So coordinate A says it should be a 4 on the x and a 1 on the y. So this would be our A inverse. All right. Our B says a 1 on the y, 1 on the x rather, and a 1 on the y. All right. This is our B. And our C says 0 on the x and a negative 1. 0 on the x and the 1 is our C image. Alright, so we're going to plot it right here. Okay. And what we want to check also is that with the properties that we have discussed, see it right here. If you all the properties, you can see the slide, right? From all these 3 points right here, you see a nice little slide which the rectangle ABC is mapped onto A inverse, B inverse, and C inverse. We're given the coordinates of C inverse. We're given the translation matrix. However, we're asked to find the object. Alright, so let's use our graph and say B inverse minus the transformation matrix is equal to the object formula. Alright, so let's look for our image. Our image was A, B in B inverse. Alright, I guess seeing the coordinates here. B, okay. Alright, so we see our object, our image right there, right? And we also see our transformation matrix is equal to 5, negative 4. Okay, A inverse B is equal to a 1, negative 2, and our C, the B prime rather, and our C prime is equal to a 2, 1. Okay, let's see, we should take that away from our transformation matrix is equal to 5 minus 4. So be equal will be our A matrix. Our A matrix will be 4 row by column, 4 minus 5, right? And then we have a 1 minus 5, and then we have a 2 minus 5. Alright, going down now, we have a negative 1. Well, the minus and the minus will give us a plus right here. Plus 4. Yes, it will give us a plus. I don't know why this can giving us so many problems. And then we have a negative 2. That will also be a plus 4. And our final answer would be a 1 plus a 4. Okay. And now we can simplify our A. This will be our B. This will be our C. So we're gonna simplify for minus 5 rather. Minus 1. 3 right there. Or B. We have a minus 4. We have a 2. And for our C we have a minus 3 and 5. For C. Alright, so we see this is our A matrix, this is our object matrix. Alright, so let's now find the coordinates of A, which is equal A. B is equal to a negative 4 and a 2, and our C is equal to a negative 3 and a 5. And let's find the coordinates. Negative 2. C now was a 2. Oh, see? It was a 2 and 1. I was wondering how our shapes don't look so identical. Alright, so we do apologize. It's our C inverse. Okay. Alright. So our coordinate B, and in trying to match these up, you know, they could be connected. So our A is our C point, right? And look at it, it's like you're sliding that shape, right? So this is our object, is our image. Right. Third, so it says under translation, T, right? Our transformation matrix T is equal to X and Y. The points are A to 2 to 3 is mapped onto A inverse minus 4 to 1. We're asked to determine the transformation matrix. So that we are not given a transformation matrix. What we will use to find the transformation matrix is inverse minus P is equal to the transformation matrix. Since we know what A is and what A inverse is, this is our A inverse, and then our A is equal to a 2 and a 3. 2 on X, 3 on our A. We know if we're just doing the matrix of A inverse, we put in the coordinates as X and Y, negative 4, negative 1, being subtracted, A matrix is equal to a 2 and a 3. Okay. Just going to subtract this, give us our transformation matrix, which is a minus 4, minus 2, minus 1, minus 3, should be equal to our transformation matrix, right? So in simplifying this now, it is equal to a minus 6 and a minus 4. That is what our transformation matrix is. Okay. We know our transformation matrix is equal to minus 6 minus 4.